Okay, so here we are. A complex number in standard form. All right, I'm going to make this a little bit. There we go. So a complex number in standard form is a plus bi. Okay, where a is the real number and bi is what's called our imaginary number. And you may be asking, well, why do we need imaginary numbers? If they're not real, why do we need them? But complex numbers, imaginary numbers, have a lot of applications. If I did a quick Google search on complex number use in real life, and these are used a lot in water and light waves, electricity, audio, video signals. Sometimes those things that you can't necessarily see, but we know that they are there. The audio waves, the light waves that are out there. Complex numbers show up in these things. Very important piece of those. So it's something that we're going to talk about here in Algebra 2. You will talk about them further if you move on in your mathematics journey to higher level math classes. All right, so big piece for us right here is this standard form, a plus bi. You have the real piece and the imaginary piece. So an imaginary number is the square root of a negative number. So we have never been able to, if you type in your calculator and you try to take the square root of -4, your calculator is going to give you an error message when you do that. And that's because the generic square root of x function is going to start here at 0, and it goes kind of in that direction. So there is not an x equal to -4 that's on that square root kind of parent graph right there. But this is going to give us an imaginary number, a complex number. And we're going to define what that is here. So the imaginary unit we call this I, is defined as the square root of -1. Okay, so that imaginary unit I is defined as the square root of -1. So the square root of -1 is equal to I. All right, so for our example up here, the square root of -4, well, that would be equal to the square root of +4 is 2. So the square root of -4 is just 2i. Okay. The next thing that we're going to talk about, the complex conjugate. The complex conjugate of a number, say if you have a plus bi, the complex conjugate is the opposite, a minus bi. So the real piece stays the same, but their imaginary parts are opposites. And we see that over here in our definition. So let's continue. Let's look at some examples here. This is asking us to find each complex conjugate. So here's our examples. Number 1, 9 minus 1i right there. So if there's nothing in front of the I, it's understood that that is a 1. So again, we're going to keep the real part the same, all right, but we're only going to change the imaginary part. So the conjugate of 9 minus I is 9 plus I. Example 2, -8i. Well, we're going to change the sign. That's a positive 8i. Number 3, 2i minus 15. We keep the real part, change the imaginary part. So this would be a negative 2i plus 15. Okay, number 4, I plus the square root of 3. So again, change the imaginary part. That becomes negative I plus the square root of 3. And I'm sorry, number 3, this should be a minus 15 because we're not changing the real portion. This should stay the same. These should all stay the same. And they do. The only thing that changes is the imaginary part. Okay? All right, so we're going to take these complex conjugates and we are going to graph them on the standard plane here. And this tells us that the x-axis is the real axis. So the x-axis is the real axis. And the y-axis is the imaginary axis. So we're going to look at some of these conjugates right here. So 2 plus 3i. All right, we're going to look at this example. All right, 2 plus 3i. And we're going to graph this on our xy plane. All right, with x being the real axis. So we see that we are at 2 in the real portion and 3i. All right, y is the imaginary axis. So 2, 3 is going to represent 2 plus 3i. Okay, let's look at another piece. So the conjugate of this, 2 minus 3i. Well, 2 minus 3i is still going to be at 2, but we're going to be at negative 3 on the imaginary axis. So that would represent that point. Let's look at some other examples here. Okay, let's look at number 2. We have negative 1 plus I, and we're going to graph this. Well, that's negative 1 on the real and positive 1 on the imaginary. So this point here would represent negative 1 plus, remember there's an understood 1 in front of the I. Let's change to our orange color for negative 1 minus I. So this is going to be at negative 1, negative 1. Okay? Look at another example. So let's look at this point here. So I'm going to call this example 3. And I'm going to give us the graph at negative 4. 1, 2, 3, 4. There is a point here. Okay? And we are asked to write that in standard form for this complex number. Well, the real version, or the real portion of this complex number is negative 4. The x-axis goes with our real axis. So this is going to be negative 4 plus, all right, we're going up 4 units on the imaginary axis. So 4i. So negative 4 plus 4i is going to represent this point on our coordinate plane.